Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to another edition of our online class. If you remember, in our last class, we talked about oxidizing and reducing agents. We defined them and we also state their features. Now we also talk about the redox reaction, and then we talk about how to test for oxidizing and then reducing agents. If you remember, also in our previous classes, we also explained what is oxidation. That means definition of oxidation and reduction in different ways. So today we are going to be looking at balancing of redox reaction. That means balancing of oxidation reduction reaction. How do we balance them? We have seen how we balance ordinary simple chemical equation like that. Let's look at how to balance redox reaction now. First of all, we look at balancing simple half equation. First of all, what we normally do here is we assign oxidation number to each of the elements in the half equation. Then after that, you balance the number of atoms on both sides. That means on the reactant and the product. They have to have the same number of atoms. Then the next thing is to add the appropriate number of electrons to account for the number of electron loss or gain. That is how to that is the steps that we will take in balancing simple half equation. Now let's take an example. Now if you look at example 1 here, we have from ion 3 to ion 2. This is a simple half equation, half redox equation. If you look at it, the number of atoms there are balanced. We have only one ion there, but the number of charges there is not balanced. Here we have +3, while here we have +2. To balance it, you have to add one electron to the left hand side. That means in the ion 3 part. And you know electron take minus and that -1. So you have here +3 -1, it becomes +2. And then this one we already have +2, so is balanced. Now let's look at another example. Another example here is from ion 0 to from zinc 0 to zinc 2. Look at the oxidation number. I've already written that the ON is oxidation number. This one is having oxidation number of 0 and this one is having oxidation number of +2. Now the number of atoms on both sides are balanced. Now let's balance the number of electrons. To eliminate this +2, we add 2 electrons to this side and it becomes +2 - 2, which is 0. So we have 0 0. So this is balanced now. Now let's look at how to balance a balanced complex redox reaction. What are the steps that we follow in balancing complex redox reaction? First of all, you identify the oxidation part and then the reduction part. After identifying that, you separate them into two half equation. That means the oxidation half equation and the reduction half equation. Then after that, you balance them separately. You balance the half equation separately. Now how do we balance it? When you want to balance the number of oxygen atom, you add the appropriate number of water. That means if you have 2 oxygen, then you have 2 molecules of water to it. And after that, then you balance the number of hydrogen atom by adding also the appropriate number of hydrogen ion. Then the next one is to balance the number of charges by adding or removing the appropriate number of electrons. It's either you add or you remove to balance the charges. And the next one is what? After balancing the number of charges, then you add the 2 balanced half equation. After you must have balance them separately, you now add them together, and then you eliminate the eliminate the electron from each of the equation. So now let's take a look at an example now. Let's take a look at an example. If you look at this, this is from heptazodichromate 6 to chromate 3. How do we balance it up? If you look at it, here we have oxygen and here we don't have any oxygen. To balance the number of oxygen, remember I said we have the appropriate number of water molecule. So we have to add how many number of water now is 7 in order to balance the oxygen. So you had 7 oxygen, 7 molecules of water here, so that the oxygen become balanced. And then here, if you look at here, we have hydrogen, but here we don't have hydrogen. How do we balance the number of hydrogen now? There we have 7 times 2, which is 14. So you had 14 hydrogen ion to this side. Now, when you had 14 hydrogen ion, the hydrogen become balanced. The next thing is to look at the number of charges now. Here we have -2, and here is +1 times 4, which is +14. So we have -2 plus 14, which give us +12. But if you look at this, +3 times 2 is +6. So we have on the left hand side we have +12, and on the right hand side we have +6. It's not balanced. So we have to balance the number of what? The number of charging by adding electron. Remember we said it's either you add or you remove. So this time around we are adding. You add how many electrons are you going to add there to make it +6? So you add 6 electrons, so that it will become +12 minus 6, and this one becomes what? +6, while this one is already +6. So this equation is balanced. Let's look at another one where we will have both the oxidation part and the reduction part. Now this is this now. An example is this. Here if you look at it from manganese 7 to manganese 2, and here from what? Iron 2 to iron 3. So this is what? This is the reduction half equation, while that of iron is the oxidation half equation. Now how do we balance it up now? No, what the next thing to do is to separate them out now. After you separate them, you also balance them separately, and that is what we are going to do now. Here we have 4 oxygen now, but here we don't have any oxygen. So that means we had to this side we had 4 molecules of water. 4 molecules of water. When we have 4 molecules of water, the oxygen there become balanced. Now here we don't have hydrogen, so that means we are going to add hydrogen to the to the left hand side now. So how many hydrogen do we add? We had, this one is 4 times 2, which is 8. So we had 8 electrons to this side. When you had 8 electrons to it, the number of hydrogen and the number of oxygen together with that of manganese become balanced. Now let's look at the charges now. The charges, here we have -1, and here we have +1 times 8, which is +8. So -1, -1. Here we have -1, and here we have -1, and here we have +1 times 8, which is +8. So -1 plus 8 give us what? +7. But here we only have +2. So how do we balance it? That means we are going to add what? How many electrons to this? We add 5 electrons to this, so that it becomes +7 minus 5, which is +2, and this one is also +2. So that means this side is also balanced. Now this side is balanced. Now let's look at the oxidation half equation now. The oxidation half equation, here we have iron 2 to iron 3. So the atoms are already balanced. Let's look at the charges. The charges, here we have +2, here we have +3. So the charges are not balanced. How do we balance it up? We add 1 electron to this one, so that it becomes what? +3 minus 1, so that they become +2 +2, and down they are balanced. Now they are balanced. Now if you look at the other hand, we had 5 electrons, and here we have only 1. To balance the number of electrons now, that means you multiply the oxidation half equation by 5 and the reduction half equation by 1, and that is what I've just done here now. So when I multiply it, this one remain the same because I'm multiplying by 1, while this one will be multiple of 5. So here we have 5 iron, 5 iron 2, 5 iron 3, and then 5 electron now. No, so after adding that, the next thing is to add up the electrons now. When you add up you add up the half equations now. When you add them up, and then you cancel up the number of electrons. So 5 we cancel 5, because we have 5 on the left hand side, we also have 5 on the right hand side, so they cancel each other, and then the equation become balanced now. Here we have, if you look at the right hand side here, we have manganese 1, oxygen 4, hydrogen 8, iron 5. Here also we have manganese 1, oxygen 4, hydrogen 8, and then iron 5. So they are balanced. They are balanced. So they are what? They are balanced now. Now let us look at the common oxidation half equation and the common reduction half equation. Here we have from 0 to +1, and here we have from -2 to 0. They are all oxidation. Here we have +4 to +6, and then here also we have from 0 to -2, which is reduction, +1 to 0, which is also reduction, and then like that. So let us look at corrosion of metal as a redox process. Why do we call it redox process? See, corrosion of metal is what? Is a slow destruction of metal, whereby you destroy a metal by chemical action. When we say chemical action, that means what? That means it involve acid. That means there is some chemical reactions there that is taking place. Now in the process, the metal is oxidized from 0 to a higher oxidation state. Like for example, for zinc now, zinc will be from zinc 0 to zinc 2, and so on like that. And that is why I have it here. This is the metal. I'm representing the metal with air. During corrosion, it is oxidized from 0 to plus a higher oxidation state. The N is, it can either be +1 or +2. So N may be 1, 2, or 3. It depends on which type of metal. And then with a release of electron, because this metal will have to release electron before it becomes oxidized. And that is why I said during the corrosion of metal by acid, the metal supply electron, which is taken up by the hydrogen ion in the acid, to what? To liberate hydrogen gas. To liberate hydrogen gas. And that is why I have given you an example here. Here we have zinc here. For example, when zinc is reacting with, let's say for example, HCl now, the zinc release the 2 electron. This is the 2 electron which will be taken up by the hydrogen ion in the hydrochloric acid, so that it will produce what? Hydrogen gas. Now this process shows that corrosion is what? A redox equation, because a particular substance is releasing electron while another one is taking up the electron. So there is going to be oxidation part and then the reduction part. Now this reduction and this corrosion is applicable to other metal apart from iron. The corrosion in iron, we call it what? Or we describe it as rusting. We all know what is rusting. We have seen when a particular nail is rusting, what happens? It becomes somehow brownish in color. What happened there is that the iron there has been oxidized. So this is my assignment for you. you balance this particular half redox equation, and then you balance also this one. This is a complex redox equation, so you balance it. And then the last one is that you should explain what is rusting. So this is where we are going to stop for today until we meet in another edition of our online class. Assalamu alaikum wa rahmatullahi wa barakatuh.